So how do you find instantaneous center of zero velocity? We're going to talk about three scenarios to find IC. To find the location of IC, we need to use the definition that says velocity of any point, for example, point B on the body is perpendicular to the relative motion of relative position vector directed from IC to the point B. So what it means is that the velocity of point B, which would be VB, the direction of VB is perpendicular to the position vector RBC from IC. So the first scenario is that of any point A on this rigid body, we know the velocity of the point A, and we also know the angular velocity of the body, which is omega. So to find the point IC, what we have to do is that the direction of VA, we have to draw a perpendicular from velocity VA, and the location of IC would be RA over IC, and we can find the RA over IC by taking VA over omega. Because we don't know VA and omega, we can find the RAC. That will be the position of IC from velocity VA. One thing we have to notice is that the position or location of IC will be always right side of the velocity VA, because the angular velocity omega must cause a clockwise angular velocity. The second scenario is that we know two velocity direction, those are non-parallel on the body. For example, point A here and point B at this point. So there is a velocity VA and their velocity VB. So VA is acting this direction at that instance, and then VB in this direction at that instance. If we draw the perpendicular, the first ever definition that we said that we are going to use to find IC. So if we draw this perpendicular, they will intersect at a point, and that point would be our IC. The distance between point A to IC is defined as a RA over position vector RAIC, and then the position vector from point B to IC is defined as RBIC. So the third scenario is that we know the magnitude and direction of two velocity on the body of 2 points A and B. This also can act in a two different way, where the direction of the velocity are in opposite direction. So here VA at point A is acting in this direction, and VB at point B is acting in opposite direction. So the IC we can find IC by proportional triangles. So if we use these proportional triangles, we can find the position IC at the cross section of this point, where the distance between VA and VB is D, which is defined by this, and we can find RA over IC by VA over omega, and we can also find RBIC with VB over omega. So this is the first option. Let's see what the second option is. In the second option, the point A and B are the velocity both direction are in the same direction, and they are on this side. VA is acting this direction, VB in this direction. So in this case, the distance D would be RBIC minus RAIC equals to D. And the arm from here to point A is the RAIC, and from this point to point B is the RBIC, and we can find this as the same way. RBIC equals to VB over omega, and RAIC is VA over omega. So this is the three ways to find IC. And now next we're going to solve some problem. But till then, thank you for watching.